this question is very similar to what we have discussed so far, but you have to calculate the holding cost and ordering cost and reorder point. So let me give you some time for you to think of. If you look at this kind of question, the first thing that you want to do is you want to look at the annual demand. What is the annual demand? What is ordering cost? And what is holding cost that you want to figure out first, and then calculate everything. So if I do that, let me switch back to my whiteboard. Oh, wow, my children are laughing. I don't know what happened down there.
How dare they?
Okay. So we know here that annual demand, so D equals, if you look at that kind of question, we know that annual demand is 15,400 units. That's what we saw. And then we see that holding cost is $26 per unit. You said per unit, per year. So you have to figure that out. And then setup cost says $75 per order, right? So that's what it is. Then you are now set to calculate EOQ, right? EOQ equals square root of 2ds over h. Then now 2 times annual demand, 15,400 times setup cost, $75, divided by h, $26. And if you calculate that, you will get 298. Now you have to calculate annual holding cost, and the annual holding cost is Q star over 2 times H, right? So that's the formula that I discussed today. So 298 over 2 times H. H is going to be $26 per order. And if you do that, you will get 3,875. Now, the other one is ordering cost. Annual ordering cost equals, so that's D over Q star times S. That's the annual ordering cost. And we know annual demand is 15,400 divided by Q star 298 times setup cost is $75. And if you calculate this, you will get actually 3,875. Let me know if I am mistaken. Are you good?
I'm confused. On the earlier slides, it said annual holding and annual ordering wasn't Q star, but it was just Q for these calculations.
Yeah. Now that you know the EOQ, right? EOQ equals, so Q star equals EOQ, economic order quantity. That's what it means. So annual holding cost can be anything, right? Any quantity that you are putting when you are ordering your inventory. So that's Q over 2 times H. But now the optimal, say, let me put here optimal. How about that? They might clarify. Optimal annual ordering cost. Then in that case, you replace Q with Q star because you are going to plug EOQ into that Q star. Does it make sense, Rocco?
Yes, that makes sense. Thank you.
Okay, good. So then, in this case, total cost will be, right? So holding cost plus annual optimal 3,875 plus 3,875 is going to be your total inventory cost. That's 150,50197,147, right? 7,750 will be your total cost of inventory in that case. Now we have RP. What is RP? RP is reordering point. Okay, so reordering point is when do we need to order it again? That's what it means. So we figured that 298 is okay. So 298 is right here, and we are going to sell annually, and we found that it's going to flowing like that. And when do we need to order it again? Reorder point. So when my inventory is reaching this point, I have to order it again, right? So this is reorder point. What is that reorder point? And reorder point is simply daily demand times lead time. Okay, that's the formula. So daily demand, what is the daily demand and what is the lead time? So I said daily demand is this delta. This delta is going to be your daily demand, and lead time is going to be this one. This is your lead time. Let me do this. Okay, this is your lead time. How long does it take for me to receive my daily my inventory? That's lead time. And in this question, you see that the lead time is 3 days. So lead time is given in this question as 3 days. It's quite fast, but say you are receiving it from China, it's going to take 1 month, 15 days at least. So that's your lead time, and the daily demand. Now daily demand equals annual demand divided by number of working days, right? So how many days we are working, and that will help you to figure the annual demand out. I'm sorry, the daily demand out. So annual demand, we know that it's already 15,400. That's our annual demand, and number of working days is given as 300 days in this question. So annual daily demand is going to be, how many is it? So 5133, right? So your annual daily demand is 51.33, and therefore RP equals 51 times 33 times 3 days. And that's 153.99, and that's about 154. So we see that when reorder point is 154, whenever you have only 154 inventory in your warehouse, then you have to order it right away. You have to order it 298, and after lead time of 3 days, your inventory will be refilled, replenished this much, and then it will go like that, depending on your demand. And when it reaches, given that your demand is constant, this point of 154, at the time you're going to order again. Then at the time you order 298, and after 3 days, you are going to be able to fill it up. It will arrive to your business place, and then it'll go back like that. So it looks like a sawtooth. So inventory management looks like sawtooth when demand is constant.
How do you say the company's name?
If I'm not mistaken, I would say Radovilsky or Radovilsky.
Okay, Radovilsky Manufacturing Company in Hayward, California makes flashing lights for toys. The company operates its production facility 300 days per year. It has orders for about 11,841 flashing lights per year and has the capability of producing 95 per day. Setting up the light production costs $49.82. The cost of each light is 96 cents. The holding cost is 14 cents per light per year.
Let me see. Okay. You see my screen, right? Good. So we're going to solve this question together. So this place, so this is called actually production Eoq model. It's a little bit different from what we have done so far. Production Eoq model. So in this case, Eoq is Eoq equals, and we say EOQP because this is production model. And EOQP, the formula is not just 2ds times h. That's not it. In this case, we say this is production model, and actually holding cost is actually this. So 1 minus daily demand. So D, and this is a lowercase, daily demand over production, daily production. So this is daily production. So where D equals daily demand and P equals daily production. Okay, so you got to remember that if we have production EOQ model, then it's a little bit variation from regular EOQ model, and this is the formula that we are going to use. And we find that D, from this question, we find that D, annual demand, is given as 11,841 lights per year, right? That's given. And also we find S, right? Annual setup cost was given as 49.82, right? So 49.82. And then we have H, annual H, as, what was that? H, The cost of each light
It
is
was
0.96. Oh, 0.14, thank you.
Yeah.
Yeah, 0.14 was with that. And then now your job is to figure out D, right? D, and we know that's going to be annual demand divided by number of working days. And it says they are working 300 days per year. So 300 days is right there. And what is it then? You know, that's 309, 4 point. Is that right? Oh no, 309.
I'm confused why annual demand and daily demand are the same number.
No, they are not the same number. Annual demand divided by number of working days. So 1141
Oh, I'm sorry.
divided by 300.
Right. Okay. Thank you.
Yeah. So again, 300 and 9 point. Is it right? 39.47. Is that correct? Let me know if it is not right.
I got that too.
Okay, good. Very good. Now P, daily production. So what is the daily production? It says, the question says that it has the capability of producing 95 per day. So it's actually given, right? 95 per day. So we know that daily production is 95. So EOQP is going to be square root of 2 times annual demand 11,841 times setup cost 49.82 divided by H.14 times 1 minus D over P, 39.47 divided by P, which is 95. And can anybody calculate this for me and find the answer? What is EOQP?
I got 3,797.
I got the
Very
same
good.
thing.
Rocco, you got the same answer?
Yeah.
Okay, very good. That confirms. So now we can calculate annual holding cost. Right? So annual optimal annual holding cost. And that is going to be, we learned before that it's going to be Q over H times H, right? Q over 2 times H was before regular model was like that. However, now H is is not like that. H has to have this parenthesis D over P, so you have to have that. So Q star, and we found 3797 as Q star divided by 2 times H.14, and then 1 minus D over P. That's 39.47 divided by P, 95. So somebody help me. It's too complicated for me calculate by myself. Did you find the answer? Anybody? Are you guys with me?
Yeah, I'm almost done calculating it.
Okay.
I got 155.
Oh, that's great. 155.
Yeah, I got the same thing.
Oh, that confirms the answer. Thank you. Very good. Now we have optimal.
I love when he says that.
That confirms the answer. Oh.
Yeah, confirms the answer. That's what I said. Optimal setup cost equals D over Q P times S. So annual demand 11,841 divided by 3797 times S 49.82 will give you the answer. And if you calculated an optimal annual holding cost correctly, then your setup cost should be 155 because it has to be same, right? Remember, the formula. So here's a total cost, and there's a Q star, right? So this is point. Here's carrying cost or holding cost. This is setup cost, and they have to meet here at Q star. Therefore, their cost in this case here setup cost equals holding cost, right? So if you did everything correctly, I know that the answer has to be same, 155, 155.
Do those values only equal each other at like the optimal levels, which is in the graph?
Right. Only at this point is right. So this is EOQ, and EOQ, the price will be the cost will be the same. If you go up there or less than that, then the cost is different. Setup cost is right here, and holding cost is right over there. So it'll be different. They're not the same. Now, the total cost, this is a little bit confusing part. Total cost for EOQ or production model equals actually annual holding cost plus annual setup cost plus production cost. So we have to add production cost over there. And so we know annual holding cost is 155 and annual setup cost is 155. We know that. Plus production cost is annually we have to make 11,841 lights, right? And what is the daily production cost? So we have a production facility working 300 days, order of 11,841. And then, do we have production cost here? Setting up light, $49. Cost of each light, cost of each light is 96. Oh, so we know that the cost of each light is 0.96. Right, so here is 0.96 is the cost of each light. Cost of each light. And if you do that, you will get the total production cost. So 300 plus this. Anybody tell me the answer?
11,677.36.
Thank you.
Yeah.
Someone got the same answer?
Yeah.
Very good. So, and you, if you are rounded up to 2 decimal places, yeah, this is going to be exact answer. 11,677.36 will be the total cost for this production model. And you are finishing your question right here.